Our project name is Study Genie, and we are group number 9. We have built a platform where we can create or share notes. We can create cheat sheets and recommend notes to other users. A user can also self-evaluate based on the cheat sheets, which is present in our application. Talking about the existing solutions, we found that these solutions basically focus on creation and they ignore how they are consumed by the audience. Our solutions is basically segmented into three modes, which is edit, cheat sheet, and the study mode, and which makes it easier for other people to collaborate and extend their notes. The key features of our note-taking applications are that we can recommend notes, we can show people whom you can follow, we can also provide a platform where you can self-evaluate based on the generated cheat sheets. There are other open social features which we have focused. They are like forking notes. You can upvote somebody's notes. This is the overall architecture where we have shown like how the Node.js instances and the Django instances are interacting with MongoDB, and it shows like how nodes are being created and are being recommended. Talking about the methodology, we have built a hybrid recommender for this note-taking application. Talking about the content-based recommendation, we use libraries like NLTK and Gensim. So we started with like we generated a document vector when a user creates any node. We pre-processed it, removing the stop words and then tokenized the words. We use the docbar function to convert pre-processed documents. We also generated a keyword profile based on the user's node. We actually aggregated all the document vectors of all the nodes created by a particular user, and we generate a keyword profile based on that. We generate recommendation based on the keyword profile. So the keyword profile is important here, where we can use rank nodes of a particular user by using some functions like cosine similarity or any kind of similarity, and we rank all those nodes in the descending order. We have got a system where a given user can follow somebody, and whenever the followee creates or updates any kind of notes, it is automatically added to the person who is following that person. So in and all, we have combined the content based and the recent followee notes as a recommendation to a particular user. We implemented collaborative recommendation so that a particular user can follow other user. The idea is like if a particular user A follows another user B and a user C also follows user B, then there's a high similarity between user A and C, so we can recommend C to A or vice versa. This is the user model which we have built. It starts from creation of nodes, building a user profile, creating a keyword profile, and then using a hybrid recommender to recommend nodes. The way we self-evaluate the cheat sheet is like we use various NLP techniques like chunking and named entity relationship. We extracted the important concepts from created nodes, and we can use these important nodes to make it invisible in a fill in the blanks kind of thing, and then we'll ask the user to fill that, and in this way a user can revise his created nodes. In evaluation, we have used a hybrid recommender, so we can check if a user actually fork or upvote any recommendation which is been given to. We can also find whether a user actually follows certain other user whom is being recommended. Mm, we can also create or conduct a controlled user study where we can judge the student performance based on this application, whether he's benefited after using this applications or how much percentage.
Okay, so now let's look at a demo of the application. So basically the user can log in or register to create a new account. And when the user registers, the first thing he gets to see is the recommended nodes, which are based on the hybrid recommender algorithm that was discussed earlier. So it's a combination of so the recommendations are based on a combination of the nodes that the user has already created, as well as the people that the user follows. So when you click on a particular node, you can see all the information that the user has created, as well as the tags that were generated based on the machine learning that we are doing, and also the cheat sheet if the user has created any. And the user can either fork the node to create a copy of it and save it for himself and improve upon it, or he can upvote it to show that it's a very useful node. And the most upvoted nodes come under the popular nodes feature. The people to follow feature is based on collaborative filtering, which also we discussed earlier. So the user can look at other users and look at their basic user profile, like what kind of nodes that they are more likely to create or more interested in. And if the user is interested in the nodes that they have created, then they can follow the other user as well.
Now let's look at the note and cheat sheet creation process in this application. The My Notes tab here shows all the notes created by the user himself, and the user can create a new note or modify an existing note. So now when we save this note, it will the machine learning system automatically parses the text to identify keywords and generate the keyword vector for this particular note. And this is also displayed in the front end. You can see at the bottom of the note. One of the aspects that we have tried to focus heavily on our application is to address the reading or studying process, which is usually ignored in other note-taking applications. The notes represent a raw form of information, but when a student studying for exams, he may wish to see more crystallized information of that. This is achieved through the cheat sheet mode, where user can organize sections into hierarchical points which can aid during study time. Additional sections can be added to the cheat sheet simply by selecting content from the note and editor and clicking the add to cheat sheet button. Users can also move the points around and collapse and expand points as shown here. Finally, to reinforce the learning from the notes, we have also created an experimental feature called study mode. In this feature, we pass the cheat sheet created by the user through the NLP process described earlier and generate a fill-in-the-blanks quiz, which the user can take in real time to better augment his understanding of the subject. To wrap up, the user can also pin notes that are most important to him. This can be viewed in the pinned tab over there, and the user can also upvote or delete the note. The following tab here shows the people you are currently following. The profile tab shows the user a snapshot of his user model, which is used to make the application adaptive and provide recommendations. Here we can see the keyword profile, which is primary input to the hybrid recommender algorithm, as well as basic statistics about his profile, such as the number of people he is following and the notes that he has created.